All right, this is the last lesson in our unit. It is about isosceles triangles. So the one thing you do need to remember about isosceles triangles is base angles are congruent, which means they are of the same value. They're the same shape and measure and all of that. So we would mark them with swoops, like we would mark, just like the sides are marked with tick marks, we would mark those base angles with swoops. So here, and the way that you see those is the sides are across from the angles. So whichever two sides are marked, it's the angles that are directly across from those. So here on number 1, what you want to look at is this angle and this angle will both be congruent. So if that bottom angle on the right is x, this bottom angle on the left will also be x. And remember that a triangle adds up to 180. So x plus 40 equals 180. So we use that to solve. So 2x plus 40 equals 180 minus 40 on both sides. And then we get 2x equals 140. And our last step is to divide by 2. So x is going to equal 70. If you're looking at number 2, you'll see that the tick marks are across from these two angles, and one is not labeled, the other one is 75. So that means this top angle is also going to be 75. Using that same rule, x plus 75 plus 75 equals 180. So then we combine our like terms here. 75 and 75 is 150 equals 180. We subtract 150 on both sides. So x equals 30. All right, looking at these problems, same idea. And this is basically the same idea through all of these. You just need to remember that the angles across from the tick marks are congruent. So this top angle up here is going to be 54 because this other bottom angle is already 54. So then we use the same rule. So 54 plus x equals 180 combined. So 108 plus x equals 180 minus 108 on both sides. So x is going to equal 72. All right, looking at number 4, you'll see you have 2 isosceles triangles, but solving for the stuff on the bottom doesn't really matter because we are told how to solve for the stuff on the top by looking at the fact that this is a 90-degree angle right here. So because that's a 90-degree angle, and we have that part of it is 28, we can solve for the other part that's inside our triangle that's kind of on like the top left. So we can do 90 minus 28 and we will get 62. So that means this angle is 62, and since that is across from the tick marks, it means this top angle will also be 62. Sorry. So then we can solve for x using that. So 62 plus x equals 180 because it's still a triangle. Combine your like terms. 124 plus x equals 180 minus 124 on both sides. So then x equals 56. All right, looking at number 5, we have to see what we have versus what we need. And the only thing we have is that the one angle on the far left is 120. So we do know that this forms a straight line, which would make it a linear pair. So 180 minus 120 is going to give me 60 for that linear pair. We also then know that these base angles are going to be congruent. So if you do 180 minus 60, you get 120. And then we have to divide it over the 2 angles. So that means each of those angles is also going to be 60 degrees. Now, here's where you have to use some of the vocab stuff that we've used before. Knowing that these 2 angles are vertical angles, so they're going to be congruent. So if that top one is 60, then this bottom one is also 60. Using what we just learned with isosceles triangles, if these two base angles, they're going to be congruent. So if one of them is 60, the other one is 60. And yet again, these are going to be vertical angles. So if they are vertical angles, they are congruent. Therefore, x equals 60. So this one's more about knowing your vocab and such rather than doing as much of the math. But this next one is a little bit more about doing the math. So still using a little bit of vocab. We have the base angles here. We have that one of them is 65. Therefore, the other one is going to be 65. So we've got to figure out this in the middle. I'm going to call it y. So y plus 65 plus 65 equals 180. No, some of you just did 180 minus 65 minus 65. That's fine as well. So y equals 130. Not y equals 130, I'm sorry. Y plus 130 equals 180. So minus 130 on both sides. So then this y value that I just added that letter in is going to be 50. So if this angle is 50, because they are vertical angles, they are congruent. This is also 50. And since these are across from the tick marks, it means they will be equal. So that one is also 50. So last equation, x plus 50 plus 50 equals 180. I know some of you may not need to set up this equation, but I'm showing it for those that do. X plus 100 equals 180 minus 100 on both sides. So x is going to equal 80. Hopefully you can see how we're using the vertical angles and such that we've been talking about in class to find out what we have, what we need, and move on from there. All right, now we're going to talk about isosceles triangle proofs, and these are going to be a little bit more difficult. They have some other things going on and a little bit of different rules that we can use based on what we just learned about isosceles triangles. So if you look at this, the very first thing you still want to do is write down your givens. So my very first given is angle D is congruent to angle E. So I'm still going to mark that. So I'm going to mark that with my single swoops the same way I've done before. Next thing we want to look at, it says A is the midpoint of DB. I'll write that. A is midpoint of DB. Yet again, that's a given. We'll talk about what that means in a minute. And then the third given is that B is the midpoint of AE. Third given. Okay, so now we're going to talk about how to mark those because midpoint has to mean something specific. So it says A is the midpoint of DB. So A is the midpoint of this section right here. And remember, midpoint means it divides it into two equal pieces. So if A is the midpoint, it means that this piece is congruent to this piece. So that's what we're going to write. DA is congruent to BA. And we can say that by definition of midpoint. Similarly, we can also say that about the second given. So that's what we're going to do. It's about AE. So B is that midpoint. So we want to say that AB is congruent to EB. So we're going to mark that. Now you'll notice it'll also have that same single tick mark. And the reason is we don't really want to have two tick marks in the middle, but we're going to show what that means here in a minute. So we can say that because the same thing, definition of midpoint. So the next thing we want to see here is that this middle segment should only really have one single tick mark. So it means that all three of those pieces are congruent to each other. So because DA was congruent to BA and EB was congruent to AB, which AB and BA is the same thing, it's just written backwards. We can then say, and this is a new property that we will not use very much, but we can say that DA is congruent to EB. And the reason that we can say that is because of the transitive property. We're not going to use that very often, but it says that if A is equal to B and B is equal to C, then A is equal to C. Basically, if two things are equal to the same, like, I don't know, I'm trying to think of a good way to explain it. Like if this orange is the same weight as that orange over there, and that orange is the same weight as that apple, then the first orange is the same weight as the apple, or something like that. Basically, they're all three the same amount. That's what we're saying here with the transitive property. So now that we have that those two triangles have that same bottom piece, we can say that the big triangle, we can say something about the big triangle because it has these congruent base angles. We can say that these sides are going to be congruent as well, because this is an isosceles triangle. I'll mark it with two tick marks so it defines it a little differently. So because those two base angles are equal, it makes triangle CDE, the big triangle, isosceles. So the way we're going to write that is DC is congruent to EC, and that is because triangle CDE is isosceles. So then, because of that, now we can say that these little triangles on the side, which is what we were trying to prove right here, so we're going to just copy that down exactly. Triangle CDA is congruent to triangle CEB by side, angle, side, because you had a set of sides, a set of angles, and a set of sides. I know that's a lot, and I know you don't have a whole lot of space on here. I did have to write this out to the side on my paper. All right, looking at what we have here, we have that our first given is going to be that ABC, triangle ABC is isosceles. That's our first given. Our second given is that D is the midpoint of AB. So then let's talk about what those both give us. They both give us something. But we are trying to prove that triangle ACD, this little triangle on the left, is congruent to BCD, the little triangle on the right. So we're trying to focus on things that will help us prove that those two triangles are congruent. So what we want to look at first is what does, I want to look at the midpoint one first. So D is the midpoint of AB. Remember, midpoint splits it into two equal pieces. So we're going to say that AD is congruent to BD. And that is going to be definition of midpoint. The next thing that I want to say is what can we get from the isosceles triangle? So from the isosceles triangle, remember we can get that two sides are congruent. So we can say that AC is congruent to BC, and that's definition of isosceles triangle. And then the other thing that I always tell you to look for is that middle line. If you have that middle line, then we can say that it is congruent to itself. So we can say that CD is congruent to CD by the reflexive property. So then we can finish off this and say that our triangles ACD is congruent to triangle BCD by side, side, side. You can actually also use side, angle, side on this. If you would have done that the base angles, angle A and angle B, were congruent, you wouldn't have had to say reflexive property. But either one is correct. One is no more right than the other one. I will go ahead and say that this one's going to be a little bit easier if you separate the triangles, only because they do overlap and it does look a little funky. So I'm just going to kind of sketch them smaller up here. So we have Q, P, and this is going to be Y. And then this one ends at X and T and S. We still need to see the whole picture because we do have some information about it. So let's look at the very first thing, that statement. I'm trying to move this over just a tiny bit. All right, so that first statement says that triangle RX Y is isosceles. That's a given. We'll talk about what that gives us in a minute. Number 2 is angle Q is congruent to angle S. That's a very basic given. We can actually go ahead and mark that. I'm going to go ahead and mark it on my big triangle. My little extra triangles that I drew. Sorry. And then number 3 is going to be that QP is congruent to ST. And that is my third given. So then QP and ST each get a single tick mark. The next thing we want to look at is, what does this give us that RXY is an isosceles triangle? So remember, an isosceles triangle has two congruent sides and congruent base angles. So that's going to be the key here. We don't really care about those two congruent sides because they're pieces of a longer side in our triangles that we're not super worried about. But we do really need those base angles because if you notice, they're the bottom angles on our triangle. So that's what we want to use from here. We want to say, and you do have to use 3 letters for these because you can't say angle X. It could be more than one thing. So we're going to say angle SXY. Actually, no, XST. Let's use T because the T is the end of that triangle. So SXT, which would be this angle right here, is congruent to angle QYP. And the reason we can say that is base angles of an isosceles, sometimes I can spell, triangle are congruent. All right, the next thing we want to look at is, since we have both of those marked, can we say that these two triangles drawn in purple are congruent? We actually can. We can say that triangle PQY is congruent to triangle TSX by angle, side. Okay, I am going to encourage you to work on the next few by yourself and then check them with the work. I am going to pause the video and write the work out and then just explain it briefly. So pause the video for yourself and try them so you can check and make sure that you are doing this correctly. All right, I went ahead and wrote out the work for both of these. Hopefully you paused it and try this on your own. You'll notice on number 1 that the base angle should be congruent. So you already know the X is 46. Then use those two angles of 46 to solve for Y. Set it equal to 180 and make sure that you solve for Y and you get 88 for angle Y. Number 2 is a tiny bit different. It's a little funky the way that it's written. It says that the two base angles, Y and X, should be different, but it doesn't necessarily always mean that they're different because you should know that base angles of that isosceles triangle are congruent. So I just rewrote that Y as an X because X equals Y. They're going to be congruent to each other. So then you can use that to solve. 40 plus X equals 180. Minus 40 on both sides, and then 2x equals 140 divided by 2, so x equals 70, and since x and y were the same, they both equal 70. All right, make sure you pause the video if you didn't and try 3 and 4, and then look for my steps and my short explanation. All right, these were a little bit strange. You do have a linear pair over here on 3. It makes a straight line, so then that means that the inside angle is going to be 40. Remember, both base angles are going to be 40. Which when you use that to solve means the top angle is going to be 100. They're vertical angles, so the one on top written in green up here is also 100. And then you have those same base angles. They're still going to be 40 because it's basically the same triangle. Therefore, that one on the outside is still going to be 140 because, yet again, it's still the same angles that you're making angle pairs with or linear pairs with. Number 4 is kind of similar in that same fashion. So because you have these base angles as both x, you have 180 equals 2x plus 75 minus 75. You get that x is 52.5. It is going to be a vertical angle here, so they're going to both be the 52.5. that x is still the same x. So because those base angles are the same on both triangles, then the top angles are both the same. It's a little funky on those, and I know y'all don't like decimal answers, but sometimes it happens. I will advise you to try this proof on your own. It doesn't have a ton of steps. It has 4 steps, so try it on your own, see if you get it. If not, then watch me. I will explain it fully. But please make sure that you are trying it. That is a very big key here. If you are not trying these on your own, you're not going to be successful on them. Just kidding. I just looked at the proof. It is actually 5 steps, not 4. So try to get it done in those 5 steps. All right, hopefully you try this on your own and you are just doing this to check your work. The only given that you have here is that T is the midpoint of RS and QP. So being the midpoint, that means that it splits it into 2 equal parts. So it means that RT and ST are congruent. So RT is congruent to ST, and that's definition of midpoint. And same thing with the other line, QT and PT are congruent. So, and we can say that by also definition of midpoint. So now we have that, and then, oops, this is, I guess it's 5 steps. I did put this together on mine, sorry. Then you'll realize that you have vertical angles here, hopefully, because that's one of the things I've told you multiple times you should look for. So angle QTR is congruent to angle PTS, and that is vertical angles congruent. And then last but not least, you can say that the triangles are congruent. QRT is congruent to triangle PST. I kind of went all over the place with my lines here. Yikes. And we can say that by side angle side. Oh, I should have put double tick marks on there with my pink line. Sorry about that. I did just fix it. So hopefully this is making more sense to you. We will do test review in class tomorrow. So please keep that in mind and keep practicing these proofs.